So today we are going to do notes on chapter 1.6. If you're kind of following along with the chapters, you'll notice that I skipped chapter 1.5 because this is word problems, and I prefer you all be here as much as humanly possible because they can get a little hard if you're not completely engaged in the lesson. So we're going to do 1.6 today. We are going to learn about, really remind ourselves about linear inequalities. So that's the greater thans, the less thans, and everything in between. We're going to do some applications in the end. So if you are in class today, then make sure you have grabbed this paper. That way you can take notes. If you're at home and have access to a printer, please make sure you're also taking notes. If you don't have access to a printer, just grab yourself a blank sheet of paper, copy these down. There's not that many questions. You don't have to write the word problems down, but make sure you know how to do these problems. I'm going to refer you back to your notes every single time. Again, this is a video through Edpuzzle. If you're not watching through Edpuzzle, then you're not getting credit for these notes. All right. I hope to see all of you back in class tomorrow. So let's go ahead and start with linear inequalities in one variable. These are the inequalities that you are used to and that you have done in Algebra 1 in previous years, maybe a little bit in Algebra 2, but mostly in Algebra 1 and 6th through 8th grade. So just kind of a reminder here, we've talked about our little faces before. So when we have greater than and less than, that means that we have an empty circle with parentheses in interval notation. If you have greater than or equal to and less than or equal to, that tells you it's a filled in circle on the graph. And we use brackets in interval notation. Now, we won't use the parentheses or brackets here, but we will use the empty and filled in circles. So the directions that I forgot to actually write out are to solve and graph. And when they tell you to graph, it's really just on a number line. And I'll tell you the particulars about my math lab and that in just a few minutes. So solving this, you just solve it just like it's an equal sign, essentially. So we need to get all the x's on one side and all the constants on the other. So to do that, we need to move this 2x to the other side. So we're going to add 2x both sides. Now, to do that, we also need to move this 5 to the other side. And to do that, we will add 5 to both sides. So I'm going to do 2 steps in 1. All right, so this leaves me with 3x plus 2x is 5x. Negative 5 plus 5 goes away, is less than, keep the sign. 6 plus 5 is 11, and negative 2x plus 2x is 0. That goes away. So now we have 5x is less than 11. To solve for x, you divide both sides by 5. Now, yes, I realize this is going to give you a fraction. Leave it in fraction form, okay? So x is less than 11/5. Now, you'll kind of need to know where 11/5 falls in the number line. And if you think about it, 10/5, 10 divided by 5, is equal to 2, right? And then 15 divided by 5 is equal to 3, right? So our 11/5 falls approximately over here. And if you want to put it in the calculator to get an actual decimal, you can do that. But it falls in between 2 and 3. We don't necessarily care where. So if it tells you to graph it, which ours will, here's our number line. We have definitely we have a 2 and a 3 on here. You have 2 and 3. Now we know our 11/5 falls in between the 2 and the 3. So I'm going to put a circle right there. Well, since it is less than and no equal to, that tells us we're going to be an empty circle, not filled in. Now, if x is less than this number, we're going to be shaded to the left. Remember, the only way you can do this and use the arrow as the direction to shade is if the x is on the left-hand side. So this is my shading to the left, including the arrow. Now, I will tell you that in my math lab, they don't use empty and closed circles. Sometimes they will, sometimes, but a lot of the times they'll use a parentheses right here. So you'll want to make sure that this is a parentheses shaded to the left instead of a bracket shaded to the left. So that's kind of what they do. Now, remember that for interval notation, they will sometimes ask you that. This is we start at negative infinity and go all the way to 11/5. And then there's a parentheses around this because it's not included. So make sure you know how to do both things. I think sometimes the homework questions do ask you to do both. Let's look at the second example on this. So here, again, we need to move x to one side and y on the other. Now, if you didn't like me last time doing 2 steps, I'm going to go ahead and do 1 step this time. So subtract 10x both sides. Now, this leaves me with 13. Then negative 7x minus 10x is minus 17x is greater than or equal to, this goes away, negative 4. Now we want to solve for x, so we want to subtract 13 both sides. This gives me negative 17x is greater than or equal to negative 4 minus 13 is negative 17. And then we divide. Negative 17 divided by negative 17. Okay, here. This is where the place that y'all forget the key part here. Key part is when you divide by a negative number, it flips the sign. So if divide by negative, we flip the sign. So here, I am going to have x, flip the sign is less than or equal to negative 17 divided by negative 17 is a positive 1. Now, if we wanted to do that on the number line, here's my number line. I'm really only going to put 1 here for now. It's less than or equal to, so we are going to do a filled in circle since it's equal to, and x is less than that number, so you shade to the left. Shading to the left. So here's my inequality. Any number, this is what this inequality means. Any number that's less than or equal to 1 will satisfy this inequality up here. If we plug in 0, that works. If we plug in negative pi, that works. If we plug in negative 7,722, that also works. But if we plug in a number bigger than 1, 1.5 will not satisfy that equation. 7.8 won't satisfy that equation. 10 won't satisfy that equation or this inequality up at the top. Okay, so this is what we're saying. All of the answers fall in this shaded region. Any one of those answers would work. Same thing over here. Any number that is less than 11/5 will work. So 0.001 would work. 2.001 would work because it's less than 11/5. If we have 11/5, that would not work because 11/5 will not be less than 11/5 when you plug it in up here. So any number that's less than that does work. All right, let's remind ourselves of domains of even roots. They take the domains up to another level this time. So let's go back and look at domains from chapter 1.2. The domain is all real numbers unless 2 things. The function is rational, aka there's an x in the denominator, right? You cannot have 0 in the denominator. Or you have an even root. So remember, you cannot take the square root or the fourth root of a negative number underneath in the radicand. So the stuff underneath needs to be greater than or equal to 0. So now they're taking this and say, okay, you've looked at this, you've tested over this, let's make it a little harder. So just as a reminder, here is my square root of x minus 6. When you have this, remember that the radicand, this is not all real numbers because it's an even root. The radicand must be greater than or equal to 0, right? So this tells me that the stuff underneath the square root, so x minus 6, must be greater than or equal to 0. And then if we solve, add 6 to both sides, x is greater than or equal to positive 6. So you can say that is your domain. You can write it in set builder notation with curly brace x such that x is greater than or equal to 6. Or you can write it in interval notation. So when we have 6, this is greater than or equal to, filled in dot, shaded to the right. So this tells me I have a bracket at 6 and then goes to infinity, parentheses around infinity always. So either one of these answers is our domain. And that's what it's asked for, the domain of even roots. Now they're about to throw a little hink in it and says, okay, what happens if I put a square root at the bottom of a fraction? So now we have two different things going on. This cannot equal 0, right, since it's in denominator. That can't equal 0 because it's in the denominator. But also, this stuff has to be greater than or equal to 0 since it's an even root. So this one is a double. Okay, so what we would initially do would be 3 minus x is greater than or equal to 0. That's what the even root tells us to do. But then, since it's on the bottom of a fraction, it can't equal 0. So what we're going to do is get rid of that equal to. So in this case, the stuff underneath the radical has got to be greater than 0. Now also, this was the bonus on your last test. So this type of question was the bonus on your last test, which I was leading up to this. So the first thing you do to solve this equation is to subtract 3 both sides. Now this gives me negative x is greater than 0 minus 3 is a negative 3. Now this is really a negative 1 times x is greater than negative 3, so we're going to divide by negative 1 both sides. Now don't forget, when you divide by a negative number or multiply by a negative number, you must flip the signs. So negative 1x divided by negative 1 is just x. Flip the sign is less than. Negative 3 divided by 1 is a positive 3. So this is our domain. Our domain has to be x is less than 3, because if it was equal to 3, you'd have 3 minus 3 is 0. The square root of 0 is 0, and you can't have 0 in the denominator. So in this case, we can't be equal to because it's in the denominator. So if we graph this, we have a 3 here. No equal to means empty circle, shaded to the left, is less than. So this one, interval notation, would be negative infinity to a positive 3. Again, order matters. There's a parentheses because it's an empty circle. Or you could also do set builder notation, which is curly brace x such that x is less than 3. Okay, moving on to our compound inequalities. So compound inequalities are and inequalities and or inequalities. So this is an and because they're smushed together. It has to be greater than some number and less than some number at the same time. So it's the overlap in the center. And or inequalities means that you're going to have one shaded on the left and one shaded on the right. So kind of remember that when you have a compound inequality like this, you're going to have some numbers and it's going to be shaded in between, okay, because x will be in between both of those numbers. And then or is shaded in opposite directions. So this would be something that this looks like, all right? Now, if we look at this first equation, this is really our inequality. This is really two inequalities smushed into one giant inequality. So really you have this inequality that says negative 3 is less than 2x plus 5. And you have this inequality that says 2x plus 5 is less than or equal to 7. So really we're solving two equations at one time. So if I were trying to get x by itself, what would I do? Well, I would subtract 5 both sides here. So minus 5, but really there's three sides of this equation or inequality here. So since we have three sides of the inequality, we're going to subtract 5 on all three sides. The biggest mistake that I see on these type of problems is that we forget to do it on all three sides. That's pretty much it. So -3 minus 5 is a -8. Bring down your sign, less than 2x, and then the 5's go away. Less than or equal to 7 minus 5 is a +2. Now go ahead and divide by 2 all three sides. And -8 divided by 2. Now again, this we are not dividing by a negative number. There's a negative number in the numerator. We did not divide by a negative number, so we're not going to flip the signs. So this gives me -4 is less than 2 divided by 2 is 1. X is less than or equal to 2 divided by 2 is 1. So remember, this tells me that I am going to shade in between -4 and 1. So let me go ahead and draw a picture. So here's my -4, here's my 1. At -4, there's an empty circle because it is a less than. At 1, it's a filled in circle because it's a less than or equal to, and it's shaded between because X is between the numbers. There is my picture. Now let's go ahead and do an interval of this. So this interval is start at -4, end at 1. -4 is a parentheses because it's an empty circle, and then 1 is a bracket because it's a filled-in circle. So again, remember this is an and conjunction problem. And with an and conjunction, that means it's shaded between. Okay, that's this one. So this one literally says the word or. If it says the word or, this is an or, which is also called a disjunction. It means it's disjointed, right? And it's shaded in opposite directions. Remember, if you see the word or, it means they're shaded in opposite directions. So really this one, if you have the word or between these two, we're just going to solve these as separate inequalities. Just take two separate inequalities and solve them like normal. So here, to solve for x on this first inequality, we will add 5 to both sides. This leaves me with 2x is less than -7 plus 5 is -2. Divide by 2. Again, the negative number is not on the bottom, so we do not flip the sign. X is less than -2 divided by 2 is -1. Or, then again, same thing. Add 5 to both sides. 1 plus 5 is 6, so we have 2x is greater than 6. Divide by 2 both sides. X is greater than 6 divided by 2 is 3. So if I graph this, this is shaded in opposite directions, which it makes sense because it is. You have a -1 and you have a 3. It's less than -1, so we're shaded to the left. And then it's greater than, so empty circle because there's no equal to on either one, and greater than 3. So we are shaded in opposite directions. So this one, if we try and do it as an interval notation, there are two separate intervals here. 1, 2. So you on your own, go ahead and do the interval notation on your own. All right, hopefully you got the same thing that I did, which was to go -infinity to -1 with a parentheses around -1 because it's an empty circle, and then 3 to infinity, parentheses around 3 because it's an empty circle. There is my inequality. So again, this tells me that I can pick a number less than -1, or a number bigger than 3, and it'll satisfy one or the other of these inequalities here. Same thing with this one. If I pick a number between -4 and 1, you could pick 1, it would satisfy this inequality at the very beginning. So this is the solution set of my answers. I can pick anywhere between -4 and 1. Okay, let's move on to our application problems. So these are our application problems. For her interior decorating job, Natalia can be paid in one of two different ways. Plan A says $250 plus $10 an hour, or Plan B, which is $20 an hour. Suppose the job takes N hours. For what values of N is Plan B better for Natalia? All right, so we're going to have two different equations here, right? So we have an equation for Plan A and an equation for Plan B. So here for A, it says $250 to start out with, then $10 an hour on top of that. It literally says plus, so we say $250 plus $10 per hour. So if you make per hour, you would multiply by the number of hours you work. So this is $10 per hour. So this is times, and it says in number of hours. So this is 10 times n. Could we have used x? Yes, but it literally told us to use n. So that's what we're going to use. Be very careful about that in my math lab. So this is the equation for Plan A. Let's look at B. It says $20 per hour. So this is just $20 times the number of hours in. This is our two different equations. Now it says for what value of n is Plan B better for Natalia? So if we want Plan B is better, that means it makes more money. So we want B to be greater than A. If they're equal, that means it's not better. That's not better. That's just equal. Okay? So we really want Plan A to be less than Plan B. Or if you want to do it the other way and say Plan B is greater than Plan A, that is completely fine. This will give you the exact same answer. So here, if we have Plan A, I'm just going to substitute the equation in. 250 plus 10n is less than Plan B, which is 20n. All right, if we solve for n here, so that means we would subtract 10n both sides. This gives me 250 is less than 10n, because 20n minus 10n is 10n. And then divide by 10. This gives you 25 is less than n. Now here's the problem. We normally are used to seeing n on the left side. So I'm going to go ahead and flip the entire equation around. When I do this, I have to mirror the sign. So here I have an n. I'm going to put 25 on the right. Now the arrow or my inequality sign is pointing towards 25. It needs to still point towards 25 here. So this tells me right here, for more than 25 hours, Plan A is less than Plan B. So if she works more than 25 hours, she should choose the B plan, right? If she works less than 25 hours, then she should choose this plan because it pays her more money. But if she works exactly 25 hours, it's going to pay the exact same. So this tells us in words, this is what this tells us, that when the job is more than $25 per hour, that tells you that Plan B is better for Natalia. That's what that tells you. Now, the next inequality we are going to come back and do after we finish chapter 1.5, because this is a building question on chapter 1.5. So now we are done with the notes. Your assignment is on My Math Lab. So that is what you need to get going on now.